Okay, so our first problem looks at car rental companies, how many cars they have in 10,000s, and then the revenue that they have in billions. So, when you do these problems, you're going to just first type everything into your calculator. Okay, when they give you the list, this is your X value and this is your Y value. If they give you one going across, then the X value is in the top, the Y value is on the bottom. Think about your independent and dependent variables. The revenue depends on how many cars you have and that sort of thing. Okay, so again, this is going to be a lot of calculator work. So you can write stuff down if you need to, whatever. Some of you may or may not need to do this, so it's probably going to be best if you just all do. First thing we have to do is turn the diagnostics on in our calculator, which sounds really crazy, but here's how it works. You're going to hit second 0 because it says catalog. Okay, so second 0 gives catalog, and this is everything that your calculator has. So you can arrow all the way down, or I push the D button, so that at least takes me to the D's, and then arrow down there, and you can see there's diagnostics off and diagnostics on. Make sure your arrow's at diagnostics on, hit enter, and then enter again, and it should say done. Okay, this should have everything now show up. If it doesn't, then you're going to have to let me know and I'll have to try to figure something out. Okay, but hopefully this will work. All right, so you've done things in list 1 before. The difference now is we're going to just put things in list 1 and list 2. So you're still going to do stat. You're going to hit enter for edit. You're going to go up and clear your lists. You probably only have things in L1. So L1 is going to be all your X values. So 63, enter, 29, enter, 20.8, enter, 19.1, enter, 13.4, enter, 8.5, enter. All right, and then just arrow over. That takes you to L2, and then you need to put all your Y values. 7, 3.9, 2.1, 2.8, 1.4, and 1.5. All right, so you have everything right there. So then you're going to hit stat and calculate, and you should hopefully be at number 4. It says linear regression, AX plus B. And we haven't talked about that yet, but we will in the next section. But that's where you need to find your R value, is right there. Okay, so you're going to hit enter. Mine, I just hit enter again, and it all shows up. Most of you probably, if you have a fancier calculator, you have to arrow down. So we'll use A and B later. You don't need to use R squared. I just want you to use R. You have to round everything to 3 decimals in this, okay? Once we get to other answers, you don't have to, but your A and B that we'll look at in the next section and R all need to be 3 decimals. So your R is approximately 0.982, rounded to 3 decimals. Okay, so that's your answer. Instead of having to do all those crazy calculations that you see on the front there, that's all you have to do is you just find it in your calculator. Okay, so now we should know, based on what we did on the front, this is really close to 1. So this should mean we have a very good positive relationship between these two. All right, we're going to test the significance though at alpha equals 0.05. So this is again what will be on your homework, only you'll want to draw a scatter plot first. Then you do the R value, then you're going to test it. So step 1, your null hypothesis is that rho is equal to 0. Your alternative is that rho is not equal to 0. Step 2, again, up to you whether you draw the picture or not, but it's always going to be a two-tailed test because it's always not equal to. We have 1, 2, 3, 4, 5, 6. So your degrees of freedom is 4. Okay, that's going to be the hard part. You have to remember to subtract 2. So two-tailed test, 0.05 down to 4, 2.776. And negative 2.776. All right. Step 3, your t value, I'll write it out here, is r square root of n minus 2 over 1 minus r squared. Again, I don't want you to use the r squared number that's in your calculator. I want you to actually just put r in there and then you'll square it in your calculator. So t equals 0.982 square root. I just put the number 4 since you already did it here. If you put 6 minus 2, you need to put that in parentheses. So it's just easier to do that part. 1 minus 0.982 squared. Okay, so when you do this in your calculator, 0.982 square root, you just do 4 divided by, then you need parentheses. 1 minus 0.982 squared. And that looks crazy because we never had a t value that big, but that's because your 0.982 is so close to 1. That means we are way far away in the critical region. Okay, so 10.4. So step 4, 10.4 is way out there, so we're going to reject our null hypothesis. Since we're rejecting it, that means we think this one is true, meaning there is a significant relationship. Okay, and now we have to describe it. And I'm going to be very picky with how you describe it. What you have to think of, and since we didn't graph it, you have to think when you graph, you put your X is going to be your cars, and your revenue is going to be your Y. All right, and since this is positive, it means it's going like this. So what you need to do is you always need to talk about going right first. So what you would say is, as the number of cars increase, or just simply the more cars you have, the more revenue you have. Okay, so you will always be increasing on the x-axis. And then you're either going to be increasing on the y, or if it was flipped, then you're going to be decreasing. But when you describe it, you always describe increasing the x value. So there is a significant relationship. The more cars a rental company has, the more revenue they will make. And that should make sense. More cars equals more money. Okay, so if this was not significant, we would stop. But since it is significant, we need to describe it. So don't describe it if it's not significant, because there's nothing to describe. Okay, but if it is significant, you need to describe it. And then you'll move on to what we're going to do in 10.2, because now there's more stuff we get to do with it.